In this video, we'll be talking about some of the ways to better design your databases such that you reduce redundancy and kind of unnecessary complexity. Okay, so the big things that we're going to be talking about in this video are ways to avoid redundancy. The other thing we're going to do is don't use an entity set when you can just use an attribute. And the third rule is limit the use of weak entity sets. Okay, so the first one, avoiding redundancy, seems really obvious. Redundancy is when you say the same thing in two or more ways. So an example of which is the Department of Redundancy department. You don't really need one of those departments. Okay, why is redundancy bad? It wastes space, and more importantly, encourages inconsistency. What do I mean by this? So if two representations of the same fact become inconsistent if we change one of them and forget to change the other. For instance, if in our database we keep track of both which Pokemon belong to each trainer, and we also keep track of, for each trainer, how many Pokemon they have. If, for instance, they release a Pokemon, and we forget to update that number of Pokemon each trainer has, we'll have an inconsistency. It's better to remove one or the other so that you don't have this redundant information. If you can calculate one from the other, do so instead of storing both of those pieces of information. Okay, so here's an example of a good entity relationship diagram. We have Pokemon here, and those Pokemon have names and positions and species, and they belong to a trainer which has a name and a badge. And note here, name is the key for trainer and position is the key for Pokemon. Okay, so this is great. However, one way that this would be a worse diagram is if for each Pokemon in our Pokemon entity, we also keep track of their trainer name here. Now, why is that bad? Because we can figure out what the Pokemon's trainer name is by going through this belongs relationship. So the trainer name here is redundant information. Now, once again, this seems kind of obvious, but I'm trying to show you examples of bad design so that you can start to recognize it. Okay, what's an example that's even worse? Well, let's say we get rid of the trainer thing here, right? We already have the trainer name associated with each Pokemon. We can just get rid of it and move badges over to Pokemon as well. So for each Pokemon, it knows the trainer's name, and it also knows the badges that that trainer has won. Now, once again, this is a much simpler entity relationship diagram. You could represent this, and we'll talk about it in a little, as just like one table, but we have a lot of redundant information here. If we have that trainer having caught multiple Pokemon, using multiple Pokemon, all of those Pokemon will have redundant information for both the trainer name as well as the badges that that trainer has won. This is a very bad entity relationship diagram. Okay, so avoid this. Break up your pieces into different parts so that you don't have redundant information. The other thing to talk about are entity sets versus attributes. Okay, so a lot of times you have to decide, do I make a whole entity set to hold this information, or do I just make it an attribute on an existing entity set? So the way that you can use to determine this is an entity set should be more than just a name. It should be more than just an ID. It should have at least one non-key attribute. Okay? If all it is just its ID, if all it is just its name, then it really should just be an attribute on whatever needs to know about that name. Okay? The other rule for when something should be an entity set is if it is part of a many-to-one or a many-to-many relationship, meaning that this particular thing could have multiple relationships with other things. And so in which case, making an entity set makes sense. So let's give some examples. So once again, here is a good example. And we're going to look at the two entities here and make sure they should be entities and not attributes. Okay? So each Pokemon belongs to a trainer. Each Pokemon here has a name, and each trainer has a name as well. Pokemon here is an example of a good entity set because it is part of a many-to-one relationship. The Pokemon can have, each trainer can catch many Pokemon, and so the Pokemon makes sense to have them be an entity set so that you can represent the fact that which Pokemon are associated with each trainer. And now trainers should also be an entity set because it has a non-key attribute. For instance here, the badges that that trainer has won. Alright, so let's pretend we didn't care about the badges. Let's pretend that all we care about is the trainer's name itself. If we don't need to keep track of that badge information, trainer doesn't need to be an entity set. So we can just make it an attribute on Pokemon. Each Pokemon has a name, and it also has a trainer. And the name is still the key here, but the trainer name is the name of the trainer that Pokemon belongs to. Okay. Last design technique is not overusing weak entity sets. So one thing that's really tempting to do is to make a whole bunch of entities weak. And the reason why you would do this is because often you're not really sure what should be a key for this entity, and if you can't come up with a key, you have to make it weak. Okay? And the problem is that they will make a lot of entities weak, and they're all supported by other entity sets. So in order to uniquely identify an entity, you have to kind of go through this chain of gathering up all of this different information together. And in reality, we tend to be pretty okay with having unique IDs for entity sets. For instance, we have things like in our database like social security numbers and automobile vehicle identification numbers. We have Pokemon IDs. We have trainer machine numbers, and etc. We often make unique IDs, and sometimes we hide them. Sometimes we keep them secret in the database, but we usually have unique IDs for many of the rows, for many of the things that we want to keep in our database. And you shouldn't be too scared to make those sorts of IDs if you need them. Okay? And in fact, oftentimes you really don't need weak identity sets. The big reason why you tend to have unique identity sets is because you don't have the authority to create a unique ID. Okay, so for example, football players have numbers on their jerseys, and it would be really nice if every football player had a unique number on their jersey. So when I want to refer to a player, I could just say they're a player number 474. However, there's a lot of reasons why we don't have each jersey having a unique number. One part is it's hard to fit large amounts of numbers on their jerseys. And so in order to uniquely identify a player, you'd have to say both their jersey number as well as their team. This makes their jersey number a weak entity here. And I also thought a good example of another sort of weak entity would be just anybody who plays for the University of Michigan.